Okay. Hi, Dr. Aline. Thank you very much. You always help us uh, with providing very good trainings and conferences and internships, so on and so forth. Our students are very excited about today's session. I gave before uh, today's lecture, I gave some brief introduction about yourself, Knime company, but it would be great if you present by yourself. Without further ado, I give the podium to you. There are more than 40 students in the class, and they're all listening to you. Thank you very much. And
Thank you. Thanks, Hamid. Hi, everybody. It's a pleasure to be here today talking to you. I just have a quick question to ask first. Did you guys already start working with Knime? Are you familiar at all with Knime? Should I give a tour of the platform at some point today or not?
they have some brief introduction. I did some data engineering and visualizations with Knime.
Cool.
So after today's session, we do our first AI application with Knime. So, but they have some understanding about Knime. They know how it works. That's it.
All right, great. So they have an idea of how the platform works. So today, the name of this guest lecture is Data Science and AI with Knime, and data science because Knime, the platform covers not only the platform, but the platform and all of our products together cover the entire data science lifecycle, but also because I will be giving a demo that uses generative AI as an alternative for traditional AI, and I'll show you how these two workflows could be developed within Knime. I will also talk a little bit about the student challenge. Hamid, did you already announce the challenge to the students?
Yes, they are working.
Okay, cool.
Actually, we also
Uh,
increased the internship opportunities to 4. So Siemens accepted 4 positions.
all right.
It makes
Yes,
me
yes.
very excited. Yeah.
Very exciting. Cool. Because I created a slide to talk a little bit about the student challenge, but I'm happy that the students already know. So without further ado, my name is Aline Bessa, as Professor Hamid said. I am a senior data scientist at Knime. And today we will be talking about the company a little bit, the software, the student challenge, and finally this AI application with analytics that I hope inspire you to work on your challenge. So Knime, the company. Knime is a software company. These days I should have updated this slide. It's actually closer to 250 employees, a bit more than 250. And it focuses on software. We don't really work with consulting. It started as a PhD project in a university in the south of Germany named University of Constance. And it has headquarters in Zurich, but offices in Berlin, Constance, which is the city that is very close to Zurich in the south of Germany, and also in Austin, Texas, in the United States. We also have a very large partner network that covers other areas of the globe. For example, right now I am talking from Brazil. We have a partner here in Brazil who takes care of our customers in South America. And we have companies that do a similar partnership with us, taking care of our customers in Asia and Oceania and other parts of the world as well. As I mentioned, Knime has software for the entire data science lifecycle. Usually, if you're using AI or not, if you're just doing some simple analytics or not, you will start your investigation, your solution, your application with data sets. These data sets do not need to be tabular, like Excel sheets or CSV sheets. They can be a set of images, they can be a set of audio files, they can be a set of PDF files. And why am I saying that? Because Knime is very powerful and is capable of handling all of these different types of files. But usually your solution, your investigation starts like that with the data. Often you have to blend the data sets in the process. Sometimes you have to transform them. For example, I don't know if you folks have studied databases, but for databases, there are some specific normal forms in which the data has to be. Sometimes if you want to create a machine learning model, you want to select what features you want to use. So this is data transformation. After you do the blending in the data transformation, you can visualize your data, your resulting data, or you can alternatively, not exclusively, but alternatively create a model based on this data. It can be a predictive model, for example, a classifier that learns patterns from this data, or a regressor, or you can do some clustering. You can create a time series model like SARIMA or ARIMA. And you can even also visualize the performance of this model using the visualization support that Knimes provide to you. And once you're done with that part, you understood the data, you did your data investigation, maybe you created a model along the way that you want to apply in practice over new data, maybe a predictive model. You often want to optimize your solution. Sometimes, for example, if you're creating a classifier, there are many different parameters that you can play with, or even different classification models that you can play with. And maybe you want to optimize that get the best one or the most efficient one. And depending on your application, you also may want to capture some parts of the solution you created to reuse in another workflow that can, for example, deploy a model that you create so that it works in practice, or you just want to capture that because maybe there is a part of the data pre-processing that is very generic and very useful for other scenarios. So you want to capture that, save it as a different workflow, and reuse that in another context. So for all of that, you can use Knime Analytics Platform, which is the product that you will be using throughout this course. Knime Analytics Platform is free, and it is also open source. And I'm assuming that you are already somewhat familiar with that, but we are going to see this in action later today. Once everything is optimized, once you have done your capturing, if you want to do that, often, especially in the context of a company, you want to deploy the solution that you create. For example, if you use all of this data to create a model that will predict the weather based on humidity, predict the temperature based on, I don't know, humidity, wind speed, season of the year. Maybe you want to deploy that such that when a new data instance comes, it can predict the temperature for that instance on the fly, right, on the go. So maybe you want to turn your model into something that can be easily accessed by other users or other pieces of software. For example, using a cloud infrastructure, or maybe you want to deploy your model as a website with a nice interface. So for deployment, you can use Knime Business Hub or a team plan in Knime Community Hub. Knime Community Hub, if you folks are not familiar with Knime Community Hub, I highly recommend that you visit this website. You can just type it up, Knime Community Hub. It's going to probably be the first link. It's hub.knime.com. And it is a repository of workflows. You can have access and download and play with all of the workflows that are public. But you can also have your own private space with your own workflows that you don't want everybody to see. Maybe you just want a few people who are also Knime Hub users to go and see those workflows. So in this infrastructure, we also have this idea of teams, and the teams can execute the workflows using a cloud infrastructure or deploy them as web services with, say, a REST API endpoints, or as a website, a standalone website with its own address and all of that. So for productionization, you use these products, either Knime Business Hub or a team plan in Knime Community Hub, and these two are paid for. This is how the company generates revenue. But the platform is totally free, no matter how complicated the solution you want to create is. I want to use generative AI. I want to use very complicated and generic visualizations. I want to integrate a Python script that I wrote 2 years ago into my solution. I want to use some geospatial analytics. It doesn't matter how complicated it is. It is free. There is an extension for Knime Analytics Platform, and it is free. So everything that has to do with creation is free and can be done in Knime Analytics Platform. Everything that has to do with putting that solution that you created into production as a standalone website, as a web service, or you use Knime Business Hub or Team Plan for that. So narrowing our focus to Knime Analytics platform, it is a tool that allows you to make sense of your data. It works for data analytics, data science, data engineering, AI applications. And as I mentioned, it is open source and it is programming, but it is visual programming. You don't have to learn any scripting language, any coding language to use an analytics platform. But the idea of using the nodes, which I will explain in a minute, and concatenating them and creating a workflow, this is programming, right? It's a finite algorithm that can be split into atomic steps, and you concatenate them. And given the same input, they should lead to the same output, right? So here we have an image of our platform's UI here in the back. And these two images at the top are two different visualizations that you can create with different nodes in the platform. There are several more, but this is just an example. So as I already hinted at, there are two very key components in the creation of a workflow, in the usage of Knime Analytics platform, and they are nodes and workflows. So nodes are the base to create a workflow. Nodes perform tasks on data. Again, this data does not need to be tabular data. It can be an image, it can be a PDF file, it can be a different type of data, but they perform atomic tasks on the data, and this is how they look like. There is the name of the node, which makes it really explicit what it does. In this case here, it splits a table. If a node has inputs, these inputs are going to come from the left side. And if this node generates outputs, not all of them generate outputs, some just generate a visualization that you see that, it cannot be reused in the workflow downstream. But most nodes do generate outputs, and you can see them available to the right side of the node. But they're not available at all times. They're only available once you execute the node, if the execution goes well. So if the node is not configured, you will see that we have this little traffic light metaphor here at the bottom of the nodes, and you will see that this traffic light is going to be red. Once the node is configured, every node needs to be configured. For example, this table splitter node here, you need to specify where you want to split this table, right? What row or what percentage should be in one of the splits and what percentage should be in the other. So you need some configuration. And once you do this configuration, it goes to yellow. And once you execute the node, the light turns green if everything worked well, and the outputs are available to the right side of the node. If an error happens, you will see a red X on top of the traffic light metaphor, and it will still be yellow. The nodes are combined to create workflows. So in this example that we have here, we start with a node that reads a CSV file. You can see that this entire workflow, all of the nodes here have already been executed because everything is green. And there is also this caption here at the bottom of the node, which is an annotation that you should do to make your workflow very readable for others. So here we explain exactly what this workflow is doing. We say that it reads a sales file that goes from 2008 to 2011. Then we have an output, which is this file already ingested within the platform. And we send this to another node named column filter that will select only a few of the columns in this file, which is a CSV file, so it's like a table. And here we explain that the columns that are selected are country, date, and amount. Next, we send this table that is smaller. Right now, we only have 3 columns to another node named row filter, which is going to exclude all of the rows in this new table that only has 3 columns, where the value for country is unknown. So the result of the row filter node is going to be a table that only has 3 columns, country, date, and amount, and we'll have no rows in which country is unknown. The cool thing of a workflow is that you can see these intermediate outputs at any time. you can always click in one of the nodes that you have already executed and see what the output was. This is very helpful when you're creating a solution because it allows you to see where you made a mistake. Maybe the configuration is not really giving what you want, or it gives you ideas on how to proceed. So it's very nice. You're able to see the result of what you are creating at any given moment, right? You can go back and forth. And after here, we have two branches. When you have two branches in a workflow or any number of branches that are parallel, it means that their executions are independent. So this top branch here, we have a duplicate row filter that, as the name says, removes rows with duplicate values in all columns. And then we send the resulting table to this visualization node, stacked area chart, and we get the sales by time. And we have a bottom branch here that executes independently of these two nodes at the top that just generates a pie chart for us with the sales by country. You can see that the nodes have different colors, and this is on purpose. In Knime, they're color-coded. Blue nodes usually correspond to visualization. Yellow nodes are the most common ones, and they correspond to data wrangling, data preprocessing. And we also have green nodes that correspond to data mining and modeling, the creation of models. We have over 4,000 nodes in Knime analytics platform, in fact. Do they all come the moment you download the platform? No. Many of them are in different extensions. If all of them came in the platform the moment you downloaded that, it would probably take a long time for you to open the platform, load everything. So when you download the platform, you get the basic, which is already very, very useful. But then depending on what you want to do, you can get different extensions, right? We have text mining extensions, generative AI extensions, geospatial process extensions, so on and so forth. And here you can see an overview of the different nodes with their color coding. So for cloud access, for example, and data access, like reading CSV files, reading tables, or big data access, so connecting with Spark, for example, or with other big data solutions, nodes are going to be mostly orange. The transformation ones, as I said, yellow. Most of the nodes for machine learning are going to be green, visualization blue, and deployment, which involves writing a table that you create in Knime into a file, or maybe connecting with a different software, like, for example, Power BI or Tableau, to send a piece of the information generated in Knime to it. We have these nodes here that are usually red. So these are just a few use cases across different departments, just to give you an idea of where Knime is used. Knime is used Siemens. Siemens is going to be important for you guys. Maybe Hamid has already mentioned, but if not, hanging there. They have been using Knime for a long time. So these are some of the commercial customers that we have, right? Continental in finance. We have marketing companies using Knime, and we actually have an entire booklet with marketing use cases, also with finance use cases, different booklets, IT, HR, different companies using Knime. Okay, so before I jump into the use case I will be covering today, I would like to check with you if you are aware of some of the details of the Knime Student Challenge. So this is the second time that we partner up with Clark University, specifically with Professor Hamid, to throw one of these challenges to the students. This year, the challenge is going to be applications of artificial intelligence in business. And these are the awards. So everybody who participates will get a digital badge showing that you participated. This digital badge can be added to your social media, to your CV. And there will also be special badges for the first, second, and third places. You get a coupon to get all of our certifications for free. Knime has lots of certifications that, again, you can brag about on your CV if you get them. And the first one is free for all, but all of the subsequent ones are paid for. And there are usually $100 and something, sometimes a bit more. So it's nice that you can take all of them for free. The coupon expires by the end of June of 2025. So make sure that you start learning about Knime and do the certifications before June 30th. I will, by the end of this presentation, show you a few links of how to get prepared for the certifications. There will also be a blog post discussing the work of the winning students. Bags with goodies. We will ship bags with a few goodies for the winning students. So first, second, and third places. Trophies as well. And finally, the star of the challenge, an internship at Siemens Healthineers for the team that places first. So I don't know if you already knew that it was going to be Siemens Healthineers, but ta-da, this is the company that will be hosting this internship. Once we have the winners decided, we can, sit down with everybody, all of the winners, and discuss all of the logistics. But for now, this is already something for you folks to know. What am I competing for? What is the real prize here? It is an internship. So do your best. Hamid is organizing the challenges theme, all of the deadlines. My understanding is that the submission deadline is for early April, right, Hamid?
Yes, 8th of April.
Okay, cool. And also, all of the evaluation criteria was determined by Professor Hamid. We will help in the evaluation. We will come and see the presentations and give our opinion, but the final word is obviously going to be Professor Hamid's. Okay, now that you are already familiar with the structure of the challenge, we can dive into the use case we have planned for you. The use case is going to be generative AI for sentiment analysis, classifying customer reviews. 1 second. Sorry, I had a technical issue here. Sorry, I was saying that the demo that we have today is for generative AI for sentiment analysis. And this is the old way through which people used to do sentiment analysis using Knime, using classic supervised machine learning. So before Gen AI became a thing, people were using supervised machine learning to generate sentiment analysis predictors with Knime. So this is an example of a workflow that uses classic machine learning. Is this too useful now that we have generative AI? Yes. In many cases, it's too useful to be able to create a model, because when you do that, you control the different variables of how the data is assessed. There is privacy too. Sometimes you don't want to send your data to a generative AI service, say OpenAI's ChatGPT. So in many ways, in many applications, it's still useful to keep things private within, say, a customer, company, and supervised machine learning comes in handy. So it is still important to learn supervised machine learning. And this is how it used to be, right? In this case here, we were building a sentiment analysis predictor for tweets. We wanted to know if tweets that were reviews of airline company experiences, so people took flights with different companies and they wanted to know what that was about, if the tweets were talking positively about the company or negatively. So we get all of these 14,000 customer tweets, and we pre-process them a little bit. Here we remove duplicate rows. We transform all of these tweets into document, which is a native Knime type. And after that, we enrich the data a little bit. This is all text mining, so I'm not going to go very deep in that. But once we use text mining to transform the data, we create a machine learning model that is trained on a big chunk of these 14,000 tweets. Say 70% of these 14,000 tweets, a model is trained, learns what word patterns map onto a positive review and what word patterns map onto a negative review. And then after that, we assess the quality of this model that we trained over the last 30% of the tweets. So this is how people used to do things. So now with generative AI, as I said, you don't have to train a model necessarily. You can do that. You can get whether or not a review for an airline company on Twitter, on X, is positive or negative using generative AI. So before, you would have to create a data set, create a model using training data, and this would require having a large label data set for effective training. But now with generative AI, you don't have to worry about creating this model, and then you don't have to worry about training, getting data that has the labels on it. So this is the structure, right? You can basically connect to OpenAI, for example, pick a model that already exists, a pre-trained model. You can enrich that model with external data. So there is this idea of vector stores. And then you can generate these predictions without needing to have labeled data to create a model. So this is the overview of the application we are going to see today in our demo. We start by reading and cleaning the data. So what data? The data that we want to get predictions for. So this is not training data. We are not creating any training model. Then we connect to the LLM. And then here, all of these nodes are going to get your credentials, get all of the different tweets for which you want a prediction, and then we go to the prompter. So this is an important concept in generative AI, right? You need to tell the generative model what the task is. You need to not only send the tweets, send the texts, and ask for the labels, but you also have to explain how you want, what is it that you want? I want the model to determine if this is a positive review or a negative review, and I want it to explain to me in a very succinct way. So this is a prompt. After we get the prompt, the output of the prompt, so we're going to have all of the tweets and these predictions that were made by the Gen AI model, by OpenAI's ChatGPT. We do some data cleaning, we clean the response that comes from this prompt a little bit, and then we evaluate our model. We evaluate the quality of, not our model, right? The model that we are reusing. So this first part here that reads the data and cleans. So the input is a data set that it's going to be, again, tweets from several American airline companies. They're not from the companies, they're about the companies. They're people complaining like, United, you messed up with my flight, or I had a very good experience at Delta, whatever. And the goal is to prepare and clean the relevant data for analysis. So here we keep a certain sentiment. We have labels for this data, but we're not using these labels to train a model. We are using these labels just later on to evaluate how well GPT 3.5 has performed. And we also filter this data just to remove some columns that we don't need and to just keep the column that contains this text here, right? So Virgin America just landed in LAX an hour after I should have been here. Your late flight bag check is not business travel friendly. So all of these, most of them are complaints, right? People usually don't go on social media to compliment the companies, right? Talk good things about the experience they had. They usually go to complain. And this is the main component here. This is the component that actually uses generative AI. So there are some components here. You need to have an account. We are using OpenAI here, but Knime provides support for many different types of large language models. We provide support for DeepSeek, for Ollama, for Hugging Face, GPT for all. So you're in no shortage of options here. But in the case of OpenAI, these are the nodes that you want to use. You have to get some credentials because you have to have an account with OpenAI. And then you send these credentials to this node, OpenAI Authenticator. And then once your account is authenticated and you're in, you can select which model you want to use. There are many different models that are available from OpenAI. In this particular example, you're using ChatGPT 3.5. And then you select this model and you send the selected model to the LLM prompter with all of the data, all of those tweets that you want the model to generate a sentiment prediction for, right? You want the model to tell for each one of those tweets if that is a positive tweet or a negative tweet. And this is how we determine the prompt for our application. Instructions: identify sentiment, evaluate the provided review, and determine its overall sentiment. The sentiment can be positive if the review expresses satisfaction, happiness, or positive emotions. Negative if the review expresses dissatisfaction, frustration, or negative emotions. And also neutral if this review is balanced, factual, or does not express strong positive or negative emotion. So when you're prompting, you have to be very specific. And then once you execute the prompter, it will run the model that you selected over each one of the tweets. And as an output, it is going to generate the overall sentiment for each one of the tweets. And this is what you get as an output. You get the response. So this comes from the large language model. These are the responses of GPT 3.5 for each one of the tweets. Each row here corresponds to one tweet. And this column here named airline sentiment is the annotation that we originally have. So a group of humans went over all of these different tweets and annotated them as neutral, positive, or negative for people to create studies like this or like the one that I mentioned originally with classic traditional machine learning. So data cleaning is what we do next, right? So this is the input here. And you want to clean this output that comes from the model and end up with a table like that, in which you only have the words that correspond to the labels in the column response. So we do some data cleaning here just to remove strings like sentiment classification, replace it with nothing. So we don't want that. We just really want the labels, neutral, positive, or negative. So this is what this part of the workflow does, just this simple cleaning. And then finally, we join the responses with the labels that we have initially, and with both columns, response and underlying sentiment, we can compare these two columns and assess how well the model is performing, right? The large language model. Ideally, we consider that the airline sentiment column that was created by humans is our ground truth. We know that humans cannot even agree on how to label things, but that's why usually you have a group and you get the majority, the opinion of the majority as the label. But this is considered the ground truth, and we're going to check how well the model performs against this ground truth. So what we want is for the values in column response to be exactly the same as the values in column airline sentiment per row. So we see that for the first row, they are the same, they coincide. For the second row, apparently the model did not get it right. Apparently the actual sentiment is positive and it's saying it's negative. Apparently the model also did not get it right for the third tweet, but then it gets it right for tweet 4, 5, and 6. But you don't want to, there are ways of doing that that are more automated. You don't want to just be looking at columns and have an idea of how well your model is performing. You actually want to compute metrics to check that. And in order to do this, we have this evaluation part of our workflow that just has this score node. And what it does is that it compares the values in these two columns and determines how well the model is performing. So our model performed correctly about 82% of the time. There are other metrics here. The model sometimes performs better for one class, not for another, but in general, this is an okay accuracy. Could be better, Sometimes you can even obtain a better accuracy with a local, classic supervised machine learning model. So it's not always that a large language model is going to perform better than a model that you train locally using classic machine learning. So keep that in mind. But this result is okay for a model that we do not even augment with vector stores or anything. So the current limitations, can AI understand passive-aggressive statements? So Virgin America, everything was fine until you lost my bag. So this is a little ironic, right? Not even passive-aggressive, but a little ironic. And humans that created the ground truth label, they understand irony and they understand that this is a negative tweet for Virgin America. But the AI said that it was neutral. So this happens quite a bit. And in order to improve this result, one can try different things. One of them is to further enrich the model with tweets and their classification, or to utilize a vector store for further enrichment. So here are some of the benefits. The main benefit is that you can perform somewhat efficient sentiment analysis of large data sets without having to train a model. So you can classify without having to label a large data set. Creating those ground truth labels, as I said, it's a lot of work. You're not going to rely on the opinion of just one person. Maybe for tweets, yes, because they're so short. But imagine if these were movie reviews, right? Or if there were many aspects in the text and each one has a different sentiment associated to it. So you start to need more humans. It's a more complicated and costly process. So in a way, using large language models, using generative AI is a shortcut that can help you get okay predictions at least. And you can improve accuracy further by enriching the model with vector stores, which is this idea of giving more information to the large language model by giving examples of positive tweets, negative tweets, already transformed into a format that can enrich the model itself locally. So this workflow can be found on Knime Hub, and I will now show in the platform. So let me share my screen again. Can you see my screen?
Yes.
Can you see the platform?
Yes.
Excellent. So this is the workflow that we just discussed. This is the data reading and cleaning. If you're already familiar with the platform, I created a folder here for Hamid, and inside is the workflow. Everything is already executed, but I can tell you how to configure things as well. So here we are specifying a data set with the tweets. I deleted this before the class, so this is why it's not here, but it's here. And you can see once the node is executed, you can see the output of this node. If it is a table, it will be easy to inspect and this panel here at the bottom, right? So this is the CSV file that I read. You can see that it's over 14,000 tweets, and you can see that the airline that they are referring to. You can see the text of the tweet. You can see the name of the user who tweeted, but a lot of this information is not necessary. So we do some column filtering here. We just keep the text. We remove everything else for the purpose of this application. We don't need to know who tweeted that or at what time. And here we create a different filter from the same original table that just keeps the ground truth information, the airline sentiment. So here at the bottom, we only have neutral, positive, or negative. And at the top, we just have the text because this is what we want to send to the large language model. So I give my credentials. They're obviously not shareable, but then I send them to the OpenAI Authenticator node, which has a very simple configuration. You don't even need to configure this node much. And once I execute it, I decide that I am going to use GPT 3.5. There are many other models that can be used now, even within the GPT family. And I'm already saying that I don't want the model to give me long responses, so I'm limiting the number of tokens. And I am also configuring the temperature for this model. So temperature is this interesting parameter that the larger the value for temperature, the more creative the model gets, and the lower this value is, the less it imagines. In a way, it helps control what became known as AI hallucinations and all of that. So also in this part of the workflow, we remove some rows. This is how the node is configured. We just keep a few rows because we don't want to, for a certain demo, we didn't want to send lots of tweets. We just wanted to send a few of the tweets just to check if everything was working fine. So we do that to get just a part of the table instead of sending more than 14,000 tweets to the large language model. We're just sending 200, and this is a way of limiting that. Then we use the column expressions node, which has now been, this is a legacy node. Now you should use the expressions node. It's more powerful. It's a new node in Knime. So instead of column expressions, just expressions. And we write the prompt here. We explain how it is. And we send the prompt to our large language model prompter along with the model we chose, GPT 3.5. So we specify here what the prompt column is, and we create a name for the response column. So the model is going to generate some kind of output, and this output is going to be in this response column. And the output of this node here is going to have this response column with the sentiment classification. But it's a little verbose, right? It has sentiment classification, neutral, blah, blah, blah. And this is why we have this data cleaning part here, in which we remove the sentiment classification part using the column expressions node. Again, we could use just the expressions node these days. String cleaner to remove white spaces. Here with the column filter, we just keep the response column in the text. And then we use the joiner node to join for each row the text we have, the response, and the original ground truth sentiment we have. And then we come here and we execute the score node, and the score node generates a nice visualization for us of the confusion matrix. And then we can see how the accuracy is somewhat high. It's, in this case, with just the 200 tweets, it's close to 83%. But we can see that this model is not performing equally well for all classes. So you can see, for example, that in the case of neutral tweets, when the tweet is actually neutral, response, which is the output of the model, is going to be correct for 44 instances and wrong for 21 instances, right? 14 positive, 7 negative. When it is actually positive, the model gets it right 47 times and wrong 4 times. So this is already much better, right? You get right 47 and wrong 4. This is much better than getting it right 44 times and wrong 21 times. And then finally, for the negative, it gets it right for 74 of the instances and wrong for 9 of the instances. There is a different way of seeing that, which is checking the accuracy statistics here at the bottom. You can see that for each one of the different classes, you're going to have different performance metrics. For example, the precision is better for the recall is better for the positive class, and the precision is better for the negative class. In general, the class neutral, the performance is not so good. I really like the F measure, which combines these ideas of precision and recall. I don't know if you folks are familiar with these two ideas, precision and recall. They're very common in classification. If I have 10 tweets that are actually positive, how many of them am I identifying as positive? So this is recall. You want coverage. You want to identify 10, all of the 10. And precision is like, I have a pool here of everything that the model identified as negative, for example. Which of these ones that were identified as negative are actually negative? So it has more to do with how clean that is, right? So Recall has to do with coverage, precision has to do with how clean it is. An F measure kind of combines both things, and here we can clearly see that the model performs best for negative, maybe because there is already this bias in the language. When people say negative things, they express this with much more emotion, and it doesn't perform as well for neutral. So there are many ways through which we can improve the performance for the other classes, but this is a bit beyond the scope of what we are discussing today. So let me go back to my presentation. So wrapping up. There are limitless resources for you to learn more about Knime, and this comes in handy, especially if you want to get the certifications, but also if you want to kill it in your project. You can use our learning center. We have self-paced courses that are completely free. We have many videos on YouTube that also give excellent introductions to generative AI, many different use cases using generative AI, and in many interesting cases using classic AI as well, classic machine learning. I highly recommend that you take a look at the channel to get inspiration for your project. We have cheat sheets in our website. Here's the link. And they have a compilation of notes that are very used for specific tasks. For example, if you have, if you're a beginner, there's a specific cheat sheet for that. We have a specific cheat sheet for classic machine learning with Knime. We have a cheat sheet for finance use cases, so nodes that people in finance use a lot. So they're varied. They're not tied to one topic or area. And we also have many booklets, which are totally free. Again, some are tied to an area, like finance or marketing, and some are tied to a topic, like text mining, and they can also be a source of inspiration for you. But for the certifications, I highly recommend that you take the self-paced courses. And finally, here's the code once again, AHADI-0625. And you can go, once you take the self-paced courses, they are split into levels, L1, L2, L3, L4. L4 comes in many different flavors. There are specialty courses. There is one on time series, there is one on text processing, one on deep learning. So after you take the courses, the next step is to go to knime.com/certification-program and take the online exams. And if you use the code, they are totally free. And then you get the badges and you put them on your CV and you put them on LinkedIn. And then you show the world that you are a pro in Knime and in data science and in AI, depending on the courses you take. So this is all I had prepared for today. Thank you very much. Let's stay in touch. This is my contact information. Do you folks have any questions?
Let me ask you, do you guys have questions from Dr. Aline? Okay. So I highly appreciate if you could share the slides and the data so students can have sort of practice on the workflow that you showed to us. It was very interesting. Thank you very much. I myself even updated my knowledge about Knime, and I think my students also are very happy. Thank you very much. It was really informative.
All right. Have a great rest of your week.
Thank you. Same to you. Have a good rest of the week. Bye.